Hey everyone, it's Mr. Davidson here. This is a follow-up video to our class from Thursday night when we were talking about amortization tables. And we talked about other things that night, and I'll put those in a separate video here soon, but I want to focus and spend a little more time on an amortization table because there seemed to be a little bit of confusion, and because an accounting class is not a prerequisite for this class, I want to go give you a little background on amortization schedules, amortization tables, why they're important, and what you need to know, just to reemphasize and build on what we talked about Thursday night. So quickly, let's talk about what is interest for a minute. Well, I looked up online a definition of interest. This one's okay. It's the amount charged expressed as a percentage by a lender to the borrower for the use of assets. In this case, the asset is money, and the borrower is us or our company, and the lender is a bank. In reality, it's the money that a bank earns and charges for the use of their money. We don't have money to go buy a machine. We need to use their money. So in turn, they allow us to use their money, but they charge us a fee. So in essence, interest is just the fee that they're charging to use their money. We need to know three things. We talked about those Thursday night. We need to know the interest rate, which is typically expressed in an annual rate. We need to know the period of which we're borrowing. Are we borrowing it for 3 years? Are we borrowing it for 12 months? What are we borrowing? What's the period? And how much are we borrowing? Are we borrowing $100,000? Are we borrowing 80% of the value? What is it that we're borrowing? Simple interest is just the loan amount times the rate. So in the example here, $150,000 loan at 6%, we'd pay $9,000 a year in interest. That's simple interest. Because we're doing an amortization and we're paying down the principal every month, we need to calculate interest a little differently, and we're going to focus on monthly payments. And because of that, we need to make our interest rate be a monthly rate. So we talked about in class, you take your annual rate, in this case 6%, divided by 12. That gives you 0.5%. Your first month's interest in this case would be $750. All right, so let's go put this to use in a spreadsheet and create an amortization schedule. So what's happened here is you've gone and found a car that you like. That car is a $10,000 car. Because it's not new, you don't get the trick financing that some new car dealers offer, 0% interest. So you have to go to the bank, or if you're in a certain profession, you may be going to the credit union, and they're going to offer you, in this case, a 7% rate. That's an annual rate, 7% interest a year. And they're only going to finance 90% of your car's purchase, and they're going to let you finance it on a 3-year note, or you're going to make payments for 3 years. And specifically, you're going to make payments for 36 months. All right, so we've agreed to a price of $10,000 with the car lot. What is your payment? And how much interest are you going to wind up paying for your car? And the real exercise here, aside from calculating a payment for financing purposes, is so you can see how much interest really does build up over time, and that you can make decisions. I've seen so many people, including some of my employees, who go get payday loans or payday loans, title loans. The interest rates you pay on those are outrageous. People will rape you in terms of interest, and that is not the right way to borrow if you don't have to. They're kind of predatory. They make money because of the circumstances that the borrower is in. That's not the type of place that you ultimately want to strive to go because of the rates being so high. So let's talk the three things we need. We need to know our loan amount. In this case, it's $9,000. We were going to pay $10,000 for the car, and the bank said they'd loan us 0.9%. I'm sorry, 90% or 0.9. Put a formula in Excel, 10,000 times 0.9, and Excel's great at doing the math. We have an annual interest rate of 7%, and we're going to borrow money for 3 years. And we're not going to change these to be monthly yet. We're going to change those in the formula. We're going to start in month 1, and we learned that little handy dandy trick on fill. I'm going to grab, oh, I don't know, 30 or 40 of these and just fill that number in. Let's see what happens. We talked about the fill. That's under the Home tab. Go over to the far right to fill. I'm going to choose fill. I'm going to fill in a series that's linear, meaning it's going to grow. It's going to grow by a factor of 1 every time it grows, and I want to go to 36 and stop. So even if I've grabbed 50 cells here, I only want it to go to 36. And it did, and it left the ones that I grabbed extra blank because we told it to stop at 36. You could have gone to here and typed 1, enter, 2, enter, 3, enter, 4, enter. And it would have done the same thing, but it takes a while. You could have also started the first 2 and then drug down, but then you got to remember, well, how far down is 36? And if I don't go far enough, it's going to stop, and that's kind of a pain too. So we're going to use the fill command to do it correctly and stay with what we originally had here. All right. So our beginning balance is our initial loan amount. For the first month, we have to go up and reference that in our data header at 9,000. And all I did was hit the plus key to tell Excel we're going to do a reference or we're going to do a calculation and reference it to cell D10. So now this cell, the beginning balance, is D10. If we change the number in D10, maybe that they come back and say, oh, we're going to pay the full amount of the loan, you can quickly change that and it will reference below. If you just type in 9,000 down here, you defeat the purpose of Excel being a dynamic tool that can change a lot of things and explode down the new result. All right, so we've got our 9,000 number, which is referenced here. Our interest for the first month is simply the loan value, 9,000, times our rate. Now, if you remember, we have to convert our rate to a monthly rate. So in algebra, you put those formulas in parentheses so they're done first. 7%, which is referenced in D11. Don't type in 7. You want to reference this so we can change that interest rate if we want to play some games and do some what-if analysis. Divided by 12. And there's our interest rate. Our payment is the payment function, but we'll walk through the long way. We're going to tell Excel, grab the formula tab, insert function. I know it's PMT, but if I didn't, I would type in PMT and search for it. There it is. And we need to know our payment. And we have 3 factors here that are bolded, 2 that aren't. The rate, the number of periods, and the present value are mandatory. We have to use those here. And the ones that are not are optional. We can use them. It'll change it to reflect some additional criteria, but we're not going to use that now. It's above the scope of this class. And Excel even tells us a little bit here. Rate is the interest rate per period. For example, 6% divided by 4 would be a quarterly payment. The number of periods is the total number of payments for the loan. And the PV is the present value, the total amount that the series of future payments is going to pay. In essence, how much we borrowed. So first we're going to go to our rate, which was 7%, but we're going to make that monthly, so we're going to divide it by 12. And Excel already gives you the answer here. It's a little over 5%. The number of periods is 3 years times 12 because there's 12 months in a year. Excel already tells us that's going to be 36. And the present value is the amount that we borrowed. It's not the beginning balance each month. It is the amount that we are borrowing because our payment will not change during this 36-month time frame. It will be the same payment the whole time. Now, we want to make this formula dynamic where we can drag it down. Right now, we haven't locked these formulas, but we do know that our interest rate is something we want to lock, D11. We're going to push the F4 key, or you can put the $ in front of each of them. We know the number of periods, which is 3 years in D12. We want to lock that too. And the amount that we borrowed, we want to lock too, because we want to we're going to pay on a $9,000 note, and our payment will not change. And if I hit enter here, Excel tells me that our payment is going to be $277.89 for each month for 36 months. Now, because this is a negative, and I kind of like all of my formulas to be positive, so I don't have to add negatives, but I can subtract positives, I'm going to edit the formula, and you do that by pushing the F2 key. That's a good shortcut key to remember. Now you can see the formula. We get our locked interest rate divided by 12, our locked term times 12, and our loan balance. I'm going to multiply that by -1 and get that to be a positive number. So how much principal did we pay? Well, we have two components in our payment, principal and interest. Our payment was $277. Our interest was $52.50. The balance of that is how much we paid down our principal. So if we tell Excel, let's do a formula. Let's take our payment, in this case E15, and subtract our interest payment of $52.50. We paid our principal down by $225.39. And what's our ending loan value? It's simply our beginning loan value minus how much we paid in principal. So at the end of the first month, if you wanted to go pay your car off, you'd have to write them a check for $87.74.61 because that's how much you owe on your car balance after the first payment. Now let's go ahead and put the formula in for month 2. The beginning balance of month 2 is exactly the same as the ending balance of month 1. And if we've done this right, we should be able to highlight this and copy them down. But whoops, what happened here? Our interest jumped from $52 to $2,193. Something's not right. If I look at the F2 and look at the formula, when I copied it down, I failed to lock the interest rate in the formula, and it went from 7% down to 300%, or 3 years. So I know I screwed up. We're going to highlight the original formula where I've got the interest rate. I'm going to lock that cell in. And if I try this again, now that I've got the cell locked, right here D11 is now locked, and I drag this down, it should work correctly. It did. And our interest is just a little bit less than what it was the previous month because our principal dropped a little bit. I'm also going to go in here and highlight all of these and make them currency so we can keep everything nice. And if I've done this correctly, because this is a relative formula to the month before, this is locked, this is locked, this is a simple calculation, that's a simple calculation. I should be able to drag this down to the bottom, 36 months, and looky there. My loan payment after 36 months is 0, and if I quickly wanted to answer the question, how much interest did I wind up paying for the car, I could do a quick sum of my interest column. And I highlight that interest column. Or I could have typed in the beginning D15 and D50 if I knew where the start and stop point was. And I'm going to pay $1,004.18 of interest. So now I've got an amortization schedule here. It tells me what my payment is, $277.89, and how much interest I paid, which is a total of $1,004.18. I'll be back with another video to show you some different functions, but this was the first one to show you the basic amortization schedule and how to do it in Excel.